Hello and Assalamualaikum to Madam Nurul Aimi. How's your day, Madam? I hope when you watch this video presentation, you will smile and understand every detail we convey. So my group and I have decided to choose this topic for our group assignment. That is spectral lines of hydrogen. Okay, let's get started. As you can see, these are the group members for this assignment. Firstly, it's me, Putri Diana, and I will be the first presenter. Next is Irene Adrina, she will be the second presenter. And the last presenter for this presentation is Nur Azlin. Okay, let me start my presentation with introduction. Electronic transition in hydrogen atom. But what is electronic transition? Electronic transition occur in atoms and molecules due to the absorption or emission of electromagnetic radiation. It has one electron attached to the nucleus, and the energy in hydrogen depends on the energy of the electron. Alright, in this topic, energy was emitted and absorbed in a transition. But how? Okay, during transition, an electron absorbs or releases energy is in the form of light energy. The energy of the photon E absorbed or released during the transition is equal to the energy change, or we call as delta E of the electron. The short way to understand is the electron absorbs the energy and jumps to a higher energy level. In the reverse emission, the electron returns to the ground state by releasing the extra energy it absorbed. Okay, we also need to know that in this topic, there are three hydrogen spectrum. There are Lyman series, Balmer series, and Paschen series. The Lyman series is in the ultraviolet, which is 400 nanometer. Balmer series is in the visible, which is around 400 to 700 nanometer, and the lastly, Paschen series are in the infrared, which is 700 nanometer. But what are the difference between them? Okay, the Balmer series release light in the visible region of the electromagnetic spectrum. Meanwhile, the Lyman series with longer arrays require the higher energy of the UV region, and Paschen series with shorter arrays require the lower energy of the IR region. Okay, so that's the intro for this topic. Let's move to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azlin, and now I will continue to present the example for this chapter. We have chosen the example which is the glowing nebula in the space. Why we choose this as the example is because the spectrum of hydrogen is particularly important in astronomy, and most of the universe is made of hydrogen. The scientists also study the emission and absorption of spectra to discover the element present, such as in nebula. Do you know what is nebula? Okay, nebula is one of the things that galaxies are made of. The other thing is like stars, black hole, and much more. Astronomers believe about 20,000 objects called planetary nebula, and 3,000 has been discovered. Okay, actually, nebula is mostly a cloud of gas and dust in space, and the basic element that present in the nebula is hydrogen with 90%, and then follow with helium with 10%, and the other thing. Do you want to know how nebula is formed? Nebula is formed when the portion of interstellar medium undergo gravitational collapse, and some nebula come from the gas and dust thrown out by the explosion of a dying star. For your information, nebula is the stellar nursery, the place where the star is born, and sometimes it's even the place where the star die. As you have already known, nebula is like a cloud of gas and dust, but how can it glowing with rich color and become the most beautiful object in the universe? Before that, you have to know that there are four main types of nebula. The first one is planetary nebular, reflective nebular, emission nebular, and absorption nebular. The glowing clouds from the space is called emission nebular. Emission nebular often found in the region of space where new stars are forming. This nebular glow when it absorbs the light of nearby stars and reach very high temperature. A star energizes the atoms in the cloud with ultraviolet radiation. As the atoms fall back to lower energy states, they emit radiation, and these nebula tend to be in red color because the abundance of hydrogen. That's why we can see the glowing nebula in the space as you can see from the picture.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irene Adrina, student ID 2020854402. So I'm going to present my part, which is about social responsibility. So first, can we see nebula? Most nebula, clouds of interstellar gas and dust, are difficult if not impossible to see with the unaided eyes or even binoculars. But the Orion Nebula is in and class nearly all by itself. It's visible to the unaided eye on a dark moonless night. You can see diffuse nebula because they either emit their own light, emission nebula, or they reflect light from nearby stars, reflection nebula. Diffuse nebula are also the birthplace of stars. Does nebula harm the environment? The answer is it does not affect. The closest nebula is the Orion Nebula at more than 1,300 light years from Earth. It is so remote that nothing that happens there can influence the Earth. The only influence is to have beautiful colors and shapes and to let us dream one day to go there and explore them. So what should we do? First, we should plan interest in ourselves so that we will be more interested to study more about stars and nebula. Second, we could visit places and support events that involve about universe and galaxy. Government must provide more foundation for better space exploration, and government should give more opportunities in space study to produce more astronauts. So these are our references about our topic. So that
Extra information. These are the difference between nebula and galaxy. Nebula and galaxy are two different things that are present inside the universe we live in. So, nebula. Nebula is a cloud of interstellar dust and other ionized gases, particularly helium and hydrogen. Nebula also cause star formation and present inside a galaxy. Nebula is a short-lived phenomenon. Next is galaxy. Galaxy, on the other hand, is a huge collection of stars that are held together by gravitational attraction. The size of a galaxy is much larger than the size of a nebula. It contains star systems, star clusters, along with interstellar dust. A galaxy, however, cannot be contained within a nebula. And lastly, the galaxies live longer than nebula. Next, I will explain four main types of nebula. First is planetary. A planetary nebula is a shell of gas produced by a star as it nears the end of its life cycle. Their name can be a bit misleading. They actually have nothing to do with plane. These nebula were given this name because they often look like planets due to their round shape. The outer shell of gas is usually illuminated by the remains of the star at its center. The ring nebula in Lyra is one of the best examples of a planetary nebula. The second one is emission. An emission nebula is a cloud of high temperature gas. Within this type of nebula, a star energizes the atoms in the cloud with ultraviolet radiation. As these atoms fall back to lower energy states, they emit radiation. The process is similar to that of a neon light. This causes the nebula to glow. Emission nebula tend to be red in color because of the abundance of hydrogen. Additional color, such as blue and green, can be produced by the atoms of other elements, but hydrogen is almost always the most abundant. A fine example of an emission nebula is the Orion Nebula. The third one is reflective. A reflective nebula differs from an emission nebula in does not emit radiation of its own. It is a cloud of dust and gas that reflects the light energy from a nearby star or group of stars. Reflection nebula are frequently the site of star formation. They usually tend to be blue in color because of the way that the light is scattered. Blue light is scattered because it more efficiently. The Trifid Nebula in Sagittarius is a good example of a reflection nebula. The last one is absorption. A absorption or dark nebula is a cloud of dust that blocks the light from objects behind it. They are very similar to reflection in composition and look different primarily because of the placement of the light source. Dark nebula are usually seen together with emission and reflection nebula. The Househead Nebula in Orion is probably the most famous example of a dark nebula. It is a dark region of dust in the shape of a horsehead that blocks the light from a much larger emission nebula behind it.
Okay everyone, that is the end for this video presentation. I hope you all can understand with our explanation and can get a new knowledge for this topic. So I think that's all from us. Thank you so much for listening and have a good day everyone. Thank you. Bye bye.